Vikas. I'm from PEC University of Technology. Today I'm going to discuss about GATE exam. GATE, which is an abbreviation for Graduate Aptitude Test in Engineering. This test is conducted by ISC and 7 of the top IITs on the behalf of National Coordination Board and MHRD. So the question arises, why GATE is so important? As the name itself is telling, GATE is an opening for a large number of opportunities that we can have through it. These opportunities are categorized into two major sections. First one is higher studies, which is very much important, and the second one is jobs. Coming to the higher study section, we can opt MTech, PhD, integrated MTech and PhD from IITs, NITs and various state universities and some other private universities which are good. So this is one of the most important opportunity for those students who fail to make to the IITs during their bachelor's time. Next, we can have some management courses like IIT Bombay is running a diploma in management courses. Next is we can go to foreign. Now some of the foreign universities are also taking admissions through GATE, like National University of Singapore is taking students on the behalf of GATE exam. So coming on to the job section, there are some PSUs like NTPC, ONGC, IOCL, BPCL, BARC. Now DRD is also through GATE, and NPCL has started taking students through GATE from the year 2017, and the various state power utilities are now also recruiting through GATE exam. From here you can get a package ranging from 8 to 12 lakhs, and there also in MTech you can get a financial assistance of 12,400, and in PhD from 25,000 to 28,000, and in MTech and PhD integrated there is provision for 25,000 rupees of financial assistance. Then nowadays some of the private sectors are also recruiting through GATE. L&T is recruiting GETs, which is Graduate Engineering Trainees, through GATE since 2015, and from 2017 Tata Power has announced to recruit students through GATE exam. So this is the importance of GATE exam. Then the next important question arises, when to start preparation for GATE. It is never too late to learn something, but better you start in the early stages. So you should start preparing from your final year, which is better. Talk about the GATE exam. The exam consists of total 65 questions. The distribution is like first 10 questions are of general ability, and the remaining 55 questions are of technical section. The general ability question consists of 5 1 marks question, and remaining 5 are of 2 marks each. In the technical section, 25 questions are of 1 marks each, and remaining 30 questions of 2 marks. The total here is 85, and from here is 15 marks. In these 85 marks, 15 marks are of mathematics, and the remaining 60 marks of technical section. So I'm going to discuss the topic mechanics of materials, which is also called strength of materials. So the subject is very much important regarding the GATE exam. As I have the past data, in 2010, SOM was asked for 6 to 8 marks. In 2015, it was asked for 12 marks, and in 2016, it was asked for 11 marks on an average. So it is one of the most important section in our mechanical stream. So I'm going to discuss one of the most important topic in SOM, which is principal stresses. The topic itself is asked for about 2 to 3 marks every year. So this is an important topic. So why do we need principal stresses? Because in our SOM problems, like we are given a beam loaded like this, a cantilever beam loaded at a end with a point load P, an axial load F, and a twisting moment say T. So from these given values, we can calculate the values of shear stress and normal stress. F over A can give us axial stress, T over ZP give us the shear stress, and P into, say the length of beam is L, P into L over Z can give us the value of bending stress. These are basic SOM equations from which we can calculate the value of stresses, but we cannot say about the maximum stresses, maximum tensile and the maximum shear stresses. To calculate these values, we need this term, principal stresses. So how to calculate principal stresses? Before going to calculate the principal stresses, we need to know about what are plane stress problems. Let us take a 2D stress element stressed like this, sigma x, which is in the x direction, sigma y in the y direction, and tau xy the shear stress applied to this member. So before starting to the calculations, we should know about the sign convention of all these values. Sigma x and sigma y are taken as positive if they are tensile, otherwise they are negative. Tau xy is taken as positive if it is generating a clockwise couple. Like in this case, tau xy is generating clockwise couple in the x phase. This is our x phase. This is our x direction, this is our y direction. So this is our x phase, this line AB. So we have to calculate the values of normal and shear stress at an arbitrarily taken plane at an angle of theta. Here the sign convention for theta is also important. Theta is measured from x phase in the clockwise direction. In this case, it is clockwise from the phase. Say if we are given the plane like this, we have to measure the value from the x phase in the clockwise direction. Then the angle will be this. So we have to remember all this while calculating or solving the plane stress problem. The same. We have taken the same case. The sign convention of normal and shear stress on the plane which is given at theta is also important. Say the shear stress be tau s and the normal stress be sigma n. sigma n is taken as positive if it is tensile. Like in this case, for this half of the member, sigma n is tensile, so it is taken as positive. Tau s is taken as positive if we split these two halves like this. This is the action. Now we take the reaction. We have made the action-reaction pair. These two pair are if they are making anti-clockwise couple, then the value of tau s taken as positive. We have to remember tau xy sign convention was positive if the couple was clockwise. But in this case, if the couple generated is anti-clockwise, the value of tau is taken as positive. So I am directly writing the expression for the value of sigma n at a given theta and tau s at a given theta. It is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta plus tau xy sin 2 theta. The expression for tau s is minus sigma x minus sigma y divided by 2 into cos 2 theta, this is sin 2 theta plus tau xy cos 2 theta. Using these expressions, we can calculate the value of normal and shear stress at any given value of theta. Now how to calculate the values of principal stresses. What is principal stresses? These are the maximum values of stress in a member. There is one more characteristic of our plane stress problem, which is of a principal plane. Principal plane is the plane at which the value of normal stress is maximum and the value of shear stress is 0. So how to calculate? Put the expression for tau s at a given theta is equal to 0. We can put this expression is equal to 0. We get the values of theta, two values of theta, say theta 1 and theta 2. If we put these two expression or values of theta in important term, which is maximum in plane shear stress. So how to calculate this value? We know the expression for shear stress, that is tau s is equal to minus sigma x minus sigma y by 2 into sin 2 theta plus tau xy cos 2 theta. If we put if we maximize this expression, we can get the value of maximum in plane shear stress. So del tau s over del theta is equal to 0. We can get the values of theta, say theta 3 and theta 4. If we put these values of theta 3 and theta 4 in this expression, we can get the values of we put these values in this value of in plane shear stress, which is maximum. But if we directly want to calculate the values of principal stresses and the maximum values of principal shear stresses, There are some direct expressions like sigma 1 and sigma 2. We can calculate like sigma x plus sigma y by 2 plus minus under the root of sigma x minus sigma y by 2 square plus tau xy square. Using plus sign we can get the value of sigma 1, and using this minus sign we can get the value of sigma 2. These are our principal stresses. The expression for tau max, in plane tau max, is this part under the root of sigma x minus sigma y by 2 ka square plus tau xy square. So using these two expressions we can calculate the values directly. There is some interrelation between these values, so we will discuss. If we have the value of sigma 1 and sigma 2, we can play with these values and calculate all other values. Like if we are given these two values, we can calculate the value of tau max directly by this expression. Tau max is equal to sigma 1 minus sigma y or sigma 2 by 2. But this is in plane. If you are asked for the maximum values of stresses at a given point, the expression will be sigma 1 by 2 or sigma 2 by 2 or sigma 1 minus sigma 2 by 2. The maximum values of these three will be our tau max at a given point. These two are different. So why do we need these sigma 1, sigma 2, tau max, these things? We have to use all these values in our theories of failure. Theories of failure. Using these theories of failure, we use these theories of failure in our machine design. This is the relevance of this topic. So now we take some problems from GATE, previous year problems basically. There is one problem which was asked in GATE 2010. The question is, the state of plane stress at a given point is given by sigma x is equal to 200 megapascals, sigma y is equal to 100 megapascals, and tau xy is given 100 megapascals. And we have to calculate the maximum shear stress in megapascals. We can directly calculate by using the expression tau max is equal to under the root of sigma x minus sigma y by 2 square plus tau xy square.